It supports static analysis of the text segment. I go through, I can either dump only text or I can dump anything that's marked as being executable. It'll go through and take the opcodes and turn them back into mnemonics and so on and so forth. We'll do ASCII dumps of .data, and then, basically we'll read the DOS header, it'll read the PE header with the COF and, or the file and optional header, so on and so forth, and display about the image data directory and the export data directory. Eventually I want to support everything. It's just, it's a very large project, not very large, but it's large enough to do all of that, and when I got down to it, I felt the way I had already started doing it was kind of wrong, where I was more parsing patterns and to some degree. I wasn't doing it like a loader, which is how I really felt that I should end up doing it. So at the moment, that's where it sets, and I'm going to start rewriting it to get it like that before I actually start adding support for the other parts of the data directories and things like that. As far as complications in parsing it, the first real handle I had is how am I going to, parse those opcodes. As I said, I only wrote this in 4 days, so it should be fairly obvious that I didn't end up writing anything to parse it myself. You have 3 basic options from everything I saw. You have, libbfd, libopcode. I don't know if anybody here has ever worked with them, but it's a fairly obvious reason why I didn't choose to do that. The biggest reason I'd say is it just does not have very good documentation. The advantage, if I had used it, is I would have had integration into GDB and other tools that based off of that. Libdisassemb, and I'm going to talk about, I believe in the next slide, why I ended up using that, writing my own, which is something I'd like to do, but just due to time constraints at the time, I didn't end up doing it. Libdisassemb was nice. It had a very low learning curve. There's only like 3 or 4 exported functions. They're fairly well defined. The interface itself isn't ugly. If you start looking at the code, it should be really portable. It's written very cleanly. It was almost all ISO C, so it should port to almost everything. It also supported Intel and AT&T syntax. That's a big one to me. Depending on what I'm doing, I enjoy both, and a lot of the Unix tools kind of only go with AT&T, whereas most of the people working in the Windows world prefer the Intel syntax, so that was a big one. And then probably the biggest selling point to me is that it actually has this functionality where you can follow, it will display or dump data by following actual flow of execution as opposed to just, address 1, address 2, address 3, or, whatever. And you have to do that via callback, and you actually deal with things like stack manipulation or anything that touches memory and so on and so forth, but it provides the ability to do kind of quasi-dynamic analysis without actually ever running the executable, which is another reason why I think it's important for me to get it set up as a loader type interface, so I can set it up just like Windows would and then run over it like this, and be able to do a lot better of a job at what it's doing right now. Next real thing that I had as far as complication, and it's really not, I just figured it was worth putting in here, is translating RVAs to physical file offsets. Wasn't incredibly hard, but they're offsets from the beginning of the file. So for any given RVA, which for anybody that doesn't know, an RVA is a relative virtual address, which is basically an offset without the base address in there. So we just take the memory mapped base of the file that we're looking at and add the RVA to it. Finding data directories was a lot more, finding or dealing with the import data directory was a lot more complicated, but another hurdle we run into with data directories themselves is that they don't necessarily start at the start of sections, and there's no direct pointer, there's no direct file offset to finding it. It was still fairly easy to find. You basically just had to go through and start looking at it and say, does this address fall within this range of addresses, or does it start at this address? If so, then we've got the section, we use the file offset, and then we know it's within there. And then if it falls inside what we're going to do is subtract the RVA of the data directory, the section RVA from the data directory RVA, and it's going to reveal the file offset, and then we'll just add that to the map to memory base address, and that'll give us the start of the data directory. If it's at the start of a section, then it's real easy. All we do is use the pointer to the raw data, or pointer to the raw data, and start going from there. Data directory gets a little more interesting. The Microsoft spec in the implementation of things that I saw were kind of two different worlds in a lot of places. What's in the data directory is going to be the list of all of the imported functions, whether it be by name or whether it be by ordinal. This is going to be one of the where I'm sitting down for 10 minutes to take a look at a program that someone found that they want me to take a look at. This is typically what I look at for the most part. What functions does it use? If the program starts opening, it does an open process and locates memory in the other process and spits text into it, then I pretty much know that it's doing something that it may or may not supposed to be doing, but it's a good indication of it. And then the specification says the import data directory is null terminated, and that's not entirely true. What I found, kind of skipping ahead of myself, but what I found was that I actually had to check the entire structures, not just for a null pointer. If I just did that, then I was running into things where it actually was, there was still data past that, so I had to do like a mem compare. And again, the IAT, the import address table, is supposed to be null terminated, and it's going to be okay, and you're supposed to have the IAT and the ILT is supposed to be the same thing until the image is bound, which again, I found was not always the case. Microsoft does some optimization. Borland does their own little thing. And what's in the specification isn't necessarily what's in the binary. And then when we actually get down in there, the integer is a bit field. If the most is set, then the function is imported by ordinal, and all we're going to be able to print out is the ordinal number, obviously. Otherwise, we can use the RVA there to actually find the name of the function. Or find the name of or find the RVA to the hint name table, rather, and inside of that, we can actually find the name of the function. There's going to be a variable length null terminate ASCII string that actually tells us what is being imported. There's only one of these, so we can actually just walk through the whole thing if we wanted to. Anyways, getting back to the problem, as I said, it's not necessarily null terminated like the specification says, but I have to test to make sure the entire structure is empty. Then also, even though the specification says that it's supposed to be both the IAT and the ILT are supposed to be the same thing, they're not necessarily the same thing. Some Microsoft are exactly what the circumstances are under Microsoft compilers, but it'll actually optimize it and stick a lot of this data in the text segment. And then Borland will actually take the ILT and initialize it to 0, and the IAT will contain the RVA. So we actually have to check both and deal with these circumstances. Otherwise, we end up with incorrect data. So if we want to find the name of an imported function, what we end up having to do is determine the address of the import data or import by going through and finding the data directory, which is it between these two addresses, and so on and so forth. As we loop through that, if we find that the whole structure is 0, then we need to exit out because we've gotten to the end. And then if we're not at a 0, or if the entire structure is not 0, then we can proceed walking down it until we find the hint name table. If it's not 0, we need to, once we determine that the entire structure is not 0, we need to check the import lookup table and 0. And if it is, then we actually need to check the IAT, and that's where I believe it was the Borland compilers that were doing that. So getting into the future of what I'd actually like to do with this, like I said, I want to make it act more like a loader. It is, right now I'm decoding the structures, or parsing the structures and so on and so forth like I would, but I'm doing it from one map to memory address, or I'm mapping it in once and not really doing the entire thing. I want to everything that's in there and have full capabilities as opposed to just limited, here's what I'm looking at, here's a small section of it, so on and so forth. The libdisassembly functionality that allows dynamic analysis to me is the biggest selling point. There's nothing, I've never seen anything that's really doing any of that without actually executing it. So to be able to do that actually gives us a lot of different functionality. And then I'd like to give it a better interface, just because I don't like the 80 by 60 displays and then trying to actually format it and figure out what you have without using something like that. It's a little bit problematic. As far as what we could build off of this is just off of, instead of just object dump itself, there's a lot of stuff you can do with antivirus, especially when you start doing the pseudo dynamic analysis. Once you start getting that in, you can start doing things like packing it or unpacking it, and then you can actually do heuristics off of that. And there's a huge gap in this right now. ClamAV is not very good. I can't think of any real Linux-based open source mail server or antivirus for mail servers that I'd say is really up to par. And to be able to do this, we could actually probably improve things a lot. And even though no one's really using, no one's /slashing whatever .exe on their Linux box, not only because it doesn't work, but there's no use for that. But where the antivirus does come into play is on mail servers and things like that. It would be interesting, to have native 32-bit Windows binary support in Linux and so on and so forth. It is a lot more complex though, and we also have to port over the user land, but then we also have the problems with, there's a lot of things like the process versus thread model of how things are actually done. Unix has no real support or no idea of opening another process and injecting code or locating memory, so on and so forth, whereas Windows does have that idea. So that would actually need to be something that would need to be emulated or would actually need to be applied at the kernel level in addition to that. So you're kind of breaking things, kind of breaking the whole segmentation model of processes and such. Do you have any questions? Actually, I think I'm running really early. Oh. So the last presentation I gave, I ended up having to go 2 hours when I was scheduled for 1, and because I had too many slides, and at this one it appears that I have too few slides. So it looks like we're probably going to get done a little bit early, but if anybody has any questions, all 10 of you. Excuse me? Okay, well, I'm going to go ahead and guess that no one does. I appreciate it. I apologize for my monotone voice, though.